is momentum, you might ask? Momentum, quantifying way of describing motion. Momentum is described in mathematical terms as P equals mv. If you have the mass of an object times how fast it goes, you get a number that is representative of momentum. It is one of the only vector quantities that does not have a unit. The other thing that we would like to talk about is our Newton's second law, which is also described by momentum. This impulse, or this force, this collision, results in a change in momentum. So hitting something makes it move. I'm going to demonstrate that here. Remember that weight and velocity are both conserved during this transition of energy here. As you can see, both balls moved due to the force of the one ball colliding with the second. By the conservation of momentum, that the momentum of the first object plus the momentum of the second object is going to equal the sum of both objects after the collision. The mass of the cue ball, which is object 1. This one, however, is stationary, so V2 is going to be represented by 0. The momentum of the first ball is going to equal the momentum of the two balls added up together after the collision. In billiards, we witness what's called an elastic collision. Both balls having their own velocity after the collision. That's because they both bounce off of one another. Kinetic energy is conserved. Now, unfortunately, I'm not able to represent what an inelastic collision is because, well, pool balls don't stick together. So, but if they did, given that these two balls are very relatively close in mass, what would end up happening is the first object would collide with the second, stick to it, and then the momentum would be conserved and they would both continue traveling in the same direction at half the speed. The reason it's half the speed is because now you are essentially doubling the mass of the moving object. That's representative in this equation here. U being equivalent to essentially what this would be if U1 and U2 were to be equal to one another, which is exactly what's happening here. Now, the second point that was made during our lecture is the idea of impact parameter. B is a variable that represents the impact parameter. If B is 0, that means that I'm hitting it dead in the center. And essentially what should happen under prime conditions is the ball will immediately go straight at a 180-degree angle from the original point in the center. If you happen to hit it off center, you then increase the impact parameter B. This is if I were to hit it dead on the side. If it were to be hit just like this, it will not go straight any longer. It will actually go at an angle. That is actually graphically represented just like this. This is what you would see for an elastic collision. The 0 meaning I'm hitting it at the center of the ball. It will go in a straight line at 180 degrees. As you start to move further away from the center, 5 being the most extreme point at the edge of the ball, the angle at which the second ball shoots off begins to decrease. It becomes a smaller angle. And the reason for this is because during an elastic collision, kinetic energy must be conserved, which implies that the speed is also conserved, which means that the only adjustable variable during this interaction is the angle of scatter. And this is actually, surprisingly, how Rutherford was able to determine that nucleuses were present in an atom in 1901. And you hit it in the dead center, it's going to go roughly in a straight line. Okay, relatively straight. If I were to adjust the impact parameter just a tiny bit, just off center enough, it'll shoot off in a smaller angle than 180 degrees. As seen there. That would roughly be somewhere in the middle of this X line here. 5 representing the far edge of the ball, so let's try to represent that. I'm going to try to hit this